Hi guys, and welcome back. This is Mr. G. We are now on lesson 2 of algebraic expressions. Okay, and I said lesson 1 and 2 we will spend this just talking about the language of algebra. So let's start off by looking at the homework that we have. We had said previously that 2x plus 3x simplifies to what? 5x. So you had to use the same understanding based also on this example here of what 3x plus 3x will simplify to. So maybe let's write 3x as x plus x plus x, right? That's what we have here. This thing is that. And then plus another one is x plus x plus x, okay? And how many? Let's count now. 1, 2, 3, 4, 5, 6. We have 6 x's, so that means the answer should be 6x, okay? And then we can do the same thing here. So again, if you're gonna rewrite this and that, you must get to 13x, okay? For C, I hope you also tried this one. You must get to what? 12b. For D, I also hope you really did this one. You must get to 19m, all right? For this one here, we now have something new, x squared, okay? But again, we just need to think about it as, oh, x squared plus x squared plus x squared, okay? That's the first one here. And then plus x squared plus x squared plus x squared, okay? Then we count 1, 2, 3, 4, 5, 6. Oh, that is just 6x squared. And then we move on here again using the same understanding. This should give us 13x squared. Okay, now if I haven't said this, I will mention it now, guys. This expression here, each of these expressions, let me write them down. 6x, 13x, 12b, 19m, 13x squared are actually what we call terms. Okay, this is a term, and a term will have two components. Okay, will have two things in it. Okay, a term will have what we call a coefficient. Okay, here's the word. Let me just not waste time and by writing it. The term, the number. Okay, so the number will be the coefficient, and this letter, the letter will be called a variable. Variable. So what is a term then? A term is a product of a number and a variable, or you can say a product of a letter and a variable. Now, what is a product? A product, guys, if you don't remember this, a product is a result of multiplication. So if I multiply 2 times x, I get 2x. And remember what I said in the previous lesson, we don't write the multiplication sign usually. That's what we do as mathematicians. So this thing here is a product, meaning you got this because you multiplied this and that. So a term, again, I repeat, is a product of a number and a variable. Are you with me? Now, let me also indicate that x is a term. Why? Because x is a product of 1 times x. Yes, that is true. We usually, remember what I said previously, we usually don't write this 1 there, okay? It's like division. When I have 2, I don't write that this is 2 divided by 1 because I know it is 2. So in the same way, when you see A, when you see B, when you see D, just know it is actually 1 times A. It is actually 1 times B. It's a product, okay? So every term that you see, it is a product. Now, here's an important thing, and I want you to pay attention here. A term, guys, it is now separated by a plus or a minus sign, okay? A term is, okay, or terms, not a term, terms rather. So when you've got more than one term, for example, let us take these two terms and add them together. Let's say 13x, okay, plus 12b. These are two terms because they are separated by a plus sign, or there is a plus sign between them. Okay, I want you to make sure that you understand that. Let's look at this one. If I have 19m, let's use a minus here, and I say minus 3x squared, guys. It is important to note that in this case, I have how many terms? Two terms, because there is a minus sign between those terms. Okay, now let me also talk a little bit about what we know so much and we can sing, which is called board mass. Board mass. We need to get this language correct. We said this is what? Brackets, okay? Brackets, order or of division, multiplication, addition, and subtraction. Now, guys, when we have more than one term and all that, we must always remember this little thing here. I know you are very good at it, okay? So I'm not gonna waste time and talk more about how to use it all that, but I want you to see how we use what the different things in both must mean. Remember brackets, if I've got brackets, they also mean multiplication. And another way to write multiplication is to actually use a dot. Okay, guys? So, in other words, if I have 2x, I can write this as 2 open bracket x. And I hope you remember when we were doing substitution, when we were evaluating expressions, you remember I used a bracket. Then I can also write this as 2 times 2. And I can also write this as 2 dot x. Excuse me here. Yes, I made a mistake there. Sorry, guys. Yes, if you saw this, you are right. This was supposed to be x. Okay, but the point here that I want you to get is that brackets, the times sign, and the dot actually mean the same thing. So you see, I've got 4 ways of writing a product. I can write a product as that or that or that or that. Okay, so watch out for these things, and they are very, very important for you to understand. Okay, so guys, I've spoken about terms. I have shown you that terms are separated by a plus or a minus sign. And then whenever you have a multiplication sign between a number and a letter, just know that it is one term. In the same way, whenever you have a division sign between a number and a letter, know that it is the same term. Why is that the case? Because x over 2 is the same as x over 1 times 1 over 2. And remember what we said. We said this operation times actually joins two terms together. I mean, not joins, not terms, joins numbers. Yes, it does join terms as well, okay? So please note this important thing here, guys, okay? Now, we have answered this, so let us bring everything nice together here, okay? In an expression that can be written as a sum, guys, the different parts of the expression are called terms. I have spoken about this. So here is an example. How many terms do we have here? Yes, I hope you said 3. Okay, now there is this thing called like terms, and there is this thing called unlike terms. What I want you to understand is that an algebraic expression, let me write an expression. Okay, here's one. Let me not write and restart. Here's one. This expression here has got how many terms? 3. Now, the question is, are those terms like or unlike? And the answer is they are like. Why are they like? Because they have the same variable or the same letter alphabet, okay? That's another important thing that you guys must understand. However, you must know that there are expressions that can have different terms, okay? Like the one that I just wrote here. This is an expression, but it has different terms. In other words, it has unlike terms. Why do we say these terms are unlike? Because in this term I have an A, in this term, I have a B. And remember, what is the number here? Yes, it's 1. And then here I have a C. So we call this unlike terms because they have different letters. Okay. Now, I had already told you that a number that is next to a letter is a coefficient, okay? And we usually call this letter a variable. I've shown you how a term looks like, okay? Now, I want you guys to also note another important thing, especially with this part. Suppose I add 3x squared plus 3x. Tell me, guys, are these terms alike? Does the term 3x squared look like the term 3x? That's a question that I'm asking. In other words, can I add these two? In other words, are these two equal? Suppose x is equal to, let's say 1. If I put 1 here, actually 1 is a bad number, not 1. Let me not use 1. Let's say x is 2. If I put a 2 here, will I get the same answer when I put a 2 there? Let us check. If I say 3 times 2 squared, what do I get? This is 3 times 4, and that gives me what? 12. If I say 3 times 2, what do I get? 6. Am I getting the same value? No. What does that mean? It means these two things are not equivalent. Not equivalent. Remember, I spoke about equivalent expressions. They are not equivalent. Therefore, because they are not equivalent, guys, I cannot add them together. Yes, I cannot add them together. In other words, these are unlike terms. So, what is one way to tell if terms are unlike? One, check if the terms are equivalent when you substitute certain x, y, or z values, whatever alphabet you are given. The second thing that you guys need to check, and this is what I'm going to talk about as I close this part of the lesson, is that what really makes these things equivalent is here the exponent is 2, but here the exponent is 1. So here's an important lesson. When you look for like terms, don't check just the letter and say the terms are like, but also check if the exponents are equal. This is very important. So without testing if these things are equivalent, by just checking both letters and the exponents, we can tell whether the terms are like or unlike. So the second checkpoint that I'm talking and mentioning here is that the letters must be the same. But the important one, exponents must be equal for each letter. Okay, so what I mean is what I said here. If I have 3x squared plus 2x, the exponents should be the same. Okay, right. Guys, I will pause here. In the next video, we will continue with our lesson and we will be exploring this idea of like and unlike terms.